Hello everyone and welcome to Revolution Games Academy. In today's video, we'll be diving into creating explosions, fire, and smoke effects in Unity. These effects utilize Unity's particle system to simulate. For this tutorial, I will be using Unity's Legacy Particle Pack to explain how these effects are made. Before starting, let me disable all the modules and explain it one by one. Let's start by examining the smoke effect. In this setup, they've also used lights and fire embers to complement the smoke, adding extra visual impact to the effect. In the smoke effect game object, the renderer uses a material with a custom shader designed to merge the RGB sprite sheet and a normal map. Custom shaders are an advanced topic which we'll cover in another video, but for now, just note that this shader allows the smoke to achieve a more realistic and dynamic look. When we enable the renderer module, the particles are emitted like a sprite sheet. The custom vertex streams are unticked for now. This feature specifies what data should be sent from the particle system to the shader, allowing it to modify particle properties dynamically. With the texture sheet animation module enabled, the sprite sheet transforms into individual waves of particles. The grid mode is used because the sprites are arranged in a grid format on the sheet. Adjusting the grid or its parameters can lead to unexpected results, such as multiple smoke sprites being merged into a single particle, which looks odd. The noise module is another essential feature as it introduces turbulence or distortion to the particle movement, mimicking the fluid and unpredictable flow of smoke. When enabled, you'll notice a significant difference in how the smoke moves, adding a lifelike feel. Rotation over lifetime is also enabled, ensuring the particles aren't static, which prevents them from appearing as straight, flat sprites. The color over lifetime module is crucial for giving the smoke its gradient effect, starting and ending with 0 alpha transparency. This creates the illusion that the smoke is emerging from nothing and slowly dissipating. The shape is set to a cone to direct the smoke upwards. The emission rate is set to 3 particles over time, with randomness applied to various properties, such as speed and rotation, to ensure each particle looks unique. This breakdown highlights how combining these modules creates a realistic smoke effect. They use the point light to create the illusion of a fire that starts the smoke, enhancing the effect and making it look much more natural. Next is the fire embers within the smoke effect. As the name suggests, this is used to simulate embers rising from the fire. A material with Unity's default texture is applied, and the render mode is set to stretched billboard to elongate the particles, mimicking embers floating upward. The noise module is enabled to introduce a randomized fluid motion, making the embers feel more dynamic. The color over lifetime module is used to create a smooth gradient from bright orange to a faded transparent end, giving the embers a glowing and dissipating appearance. In the shape module, a cone is used with a wider angle to spread the embers outward. When this module is enabled, you can observe the embers scattering more naturally. The emission rate is set to 30 particles per second, with the start color defined as a bright orange. The start speed is moderate to ensure the embers rise gently, while the size is minimized and paired with a short lifetime to keep the particles subtle and unobtrusive. These small adjustments collectively create an ember effect that complements the smoke seamlessly. For the fire effect, 3 particle systems were combined to achieve a realistic result. In the flames particle effect object, they used a particle standard unlit material along with a custom fire sprite sheet. The sprite sheet was modified to achieve the desired animation, and when the render mode is enabled, the sprite sheet becomes visible. By default, the particles don't move because the start speed is set to 0. To animate the fire, they added the texture sheet animation module, which cycles through the frames of the sprite sheet, creating the appearance of flickering flames. Additionally, the noise module was used to add turbulence and distortion to the particle movement, giving the fire a more unpredictable behavior. It adjusted the noise separately for each axis, creating a flowing effect. The color over lifetime module was also utilized to simulate the natural gradient of fire, transitioning from bright orange to a subtle fade. To enhance the fire's realism, they applied the velocity over lifetime module to add slight upward motion to the flames, mimicking how fire rises. The shape module was set to a circle with a reduced radius, ensuring the sprites are distributed within the circular boundary to create a concentrated fire effect. Lastly, they increased the simulation speed to control how fast or slow the flames animate. Tweaking this value drastically changes the behavior of the fire. A carefully chosen size and lifetime ensured the fire's flames look natural and consistent. For the light object, the render mode was set to none because they didn't need a material to render. Instead, the lights module was enabled to simulate the glow and illumination from the fire. The light used was a prefab, which was made with a light component emitting a light in the ground with custom settings for range and intensity in lights module, and the light's color was set to a warm yellow to match the fire. This light was emitted at intervals controlled by the emission module, creating a pulsing effect. In the main module, they adjusted common settings to fine-tune the light emission as needed. Notably, the culling mode was set to pause and catch up, meaning the system stops simulating while off-screen. When the fire re-enters the view, it performs a large simulation step to catch up. While this can improve performance, in more complex systems, this option causes performance spikes. Finally, they incorporated the fire ember effect that we previously analyzed. Together, these systems, flames, light, and embers, create a cohesive and immersive fire effect. For the explosion effect, 6 particle systems and 2 sub-emitters are used. Here's the breakdown. Big explosion effect object. This system handles the smoke emerging from the explosion. Similar to the smoke system we discussed before, it is darker to represent the dense aftermath of an explosion. A normal map is used to add texture and detail to the smoke, creating a more realistic look. You can observe how enabling or disabling the normal map affects the overall appearance, adding depth and definition to the smoke. The emission module is set to burst mode to release all particles in at the same time, creating an explosion-like smoke effect. Next is the light. This system is similar to the previous fire light system, except here the lifetime is shorter. The light vanishes before another light is emitted because of short lifetime of the particle. Here, intensity and range of the light are set higher to producing an intense flash when exploding. Embers. Ember system is also similar to the fire ember system, but here it emits particles in burst mode, and in the shape module, it uses a hemisphere shape, ensuring the embers scatter widely and simulate the effect flying outward. This wide scattering adds more beauty to the explosion. Next is this shockwave object, which uses mesh-type render mode, allowing the shockwave to have this sphere mesh. This material uses Unity's built-in legacy shader. The size over lifetime module is used to give the shockwave a gradual expanding effect over its lifetime, and color over lifetime uses a gradient with reducing transparency. So the shape module is set to sphere, and the emission is burst mode with time interval, creating a timed shockwave every few explosions. Fire object. This system uses the same material as the regular fire we discussed earlier, but with some changes. The emission is set to burst mode, and the shape module is adjusted to sphere, creating an intense spherical burst of flames at the core of the explosion. The final main particle system used in this explosion effect is debris. This system represents small destroyed pieces flying away from the explosion. Here, the render mode is set to mesh, and the material applied uses Unity's standard shader, which includes a normal map. This normal map adds surface details such as curves, dents, and roughness, enhancing damage details on the particle. They used burst emission and the shape to hemisphere, with higher radius to create scatter effect. Let's slow the playback time in particle effect panel and see what happens. You can see that no debris are being rendered. This is due to a missing mesh, so I will add a mesh, which I modified. Now when I play the system again, you can see the debris being emitted. This system contains two sub-emitters that are triggered at birth, meaning these particles will be emitted along with generated debris. First sub-emitter emits smoke particles similar to the smoke system we discussed earlier. However, rate over distance is used here to emit particles based on the distance traveled by the debris. The shape is set to sphere, ensuring particles are emitted evenly from the debris. Second sub-emitter emits fire particles but with a different shader. The emission and shape settings are similar to the first sub-emitter, ensuring both systems synchronize in time and movement. When I turn off the second sub-emitter and play, you can see the smoke coming out with the debris. And when I turn on this sub-emitter and disable the first sub-emitter, you can see the fire coming out. When played together, smoke and fire is emitted along with the pieces. When we reset the playback and play the system, you can see that they make this stunning effect of destroyed pieces catching fire and smoke and being scattered. The combination of these systems and sub-emitters creates this visually complex explosion. And that's it. We've dismantled and understood how all these effects are made. You can't fully learn this just by watching. Make sure to create them yourself and experiment with different settings to deepen your understanding. If you have any questions or want to see more advanced tutorials, let me know in the comments. Make sure to like, subscribe, and hit that notification bell so you don't miss out on future videos. Thanks for watching, and I'll see you in the next tutorial.